Hello everyone, my name is Go Wei Hong and my student ID is MAT2509046. Today I'm going to talk about very important topic from our MAT101 course, the standard equation of the ellipse. Before I start, I want to thank our lecturer Dr. Darren Ong Chong Lee for helping us this semester. Okay, let's begin. First, let's look at what we will learn today. My goal is to help you understand the definition of an ellipse and the math we use to find its parts. You might ask, why are the ellipses important? Well, in the real world, the planets do not move in perfect circles around the sun. They move in ellipse. If we understand this equation, we can predict how planets move in space. Let's go to slide 3. So, what is an ellipse? In geometry, an ellipse is a set of points. For every point on the ellipse, if you add the distance from two fixed points called 4c, and total distance is always the same. Look at the diagram on the slide. Imagine you have a string tied to two pins at F1 and F2. If you pull the string tight with a pencil and draw a loop, you get an ellipse. As you can see in the formula, the distance from F1 to point P plus the distance from F2 to point P is always equal to 2a. This 2a is the length of the long part called the major axis. Slide 4. Before we do the math, let's learn the body parts of an ellipse. First part is the center, which is H and K, is the middle point. Second one is the vertex, are the two ends of the long line. Third one, the major axis is the longest line through the middle. Its length we call 2a. Conversely, the minor axis is the shortest line through the middle. Its length is 2b. Lastly, c is the distance from the center to each focus. We will use these three letters A, B, and C to write our equation. Slide 5. Now, let's look at the standard equation when the ellipse is horizontal, meaning it is wide like a football. The bigger number is under x. The equation is x squared over s squared plus y squared over b squared is always equal to 1. Remember this simple rule. For an ellipse, A is always bigger than B. Since it is wide, our vertices are at plus or minus A and 0, and our 4C are at plus or minus C and 0. To find the value of C, we use this formula, C squared equal to A squared minus B squared. Next slide is our slide 6. Slide 6. What if the ellipse is vertical and stand up tall? In this case, the bigger number, A squared, move to be under the Y. The equation becomes x squared over b squared plus y squared over s squared equal to 1. Now, the vertex and 4c are on the y-axis, so the vertex will become 0 and plus or minus a, and the 4c will become 0 and plus minus C. A good tips for your exam, always look for the bigger number at the bottom. It tells you if the ellipse is wide or tall. Slide 7. So far, we look at ellipse with the center at 0, 0 is always the origin. But what if the center moves to a new place like H and K? Look at the formulas here. We just subtract H from X and subtract K from Y. This is called a translation. The shape of the ellipse stays exactly the same. A, B, and C do not change. Only the position on the graph move to a new spot. Like it. Let's try a real example. Suppose we have the equation 9x squared plus 25y squared equal to 225. We need to make it look like the standard form. To do this, we must make a right side equal to 1. So we divided every part of the equation by 225. After we simplify the numbers, we get x squared over 25 plus y squared over 9 equal to 1. Now we can see our value. A squared is 25, so we know A is 5. And also B squared equal to 9, so we get the value of B is 3. Okay, for slide 9, now let's find the other parts. Since the bigger number, 25, is under X, we know this is a horizontal ellipse. The vertices are at 5, 0 and negative 5, 0. Next, we find the focus distance, which is C. C squared equal to 25 minus 9, which is 16. So C is 4. This means our for C are at 4, 0 and negative 4, 0. By doing these simple steps, we can find everything about the shape. Okay, for slide 10, here is a summary table. To finish, let's look at this summary table. It compares the two types, wide and tall. The most important things to remember are the formula C squared equal to A squared minus B squared, and that A is always the biggest distance. And also we can see the eccentricity on horizontal is E equal to C over A, and the vertical will be same. And for standard equation, horizontal and vertical, the difference between them, just the A and B change their location. For last slide, this is end of my presentation. I hope this explanation will clear and helps you with your studies. Thank you for listening and your attention to me today. If you are watching on YouTube, please leave a question if you have one. Goodbye.